Hello class, this is Dr. Hux and this is part one of two videos we'll present on multiple regression. This first part is going to deal with running the multiple regression test, and part two will be dealing with how you do the pre-tests for running the multiple regression test. So in my first overview, I showed you this video. Multiple regression identifies the variables that predict continuous outcomes. And there's some terminology involved in these variables. A predictor variable is thought to be associated with the continuous outcome. Predictor variables can be categorical or continuous. Multiple regression can process multiple predictor variables. We talked about this equation pretty much in depth in the overview, so I'm not going to spend much time on that. And we talked about this table. This is the ultimate table that you will get from processing a multiple linear regression. Terminology: the primary goal of multiple regression is to build a parsimonious model. I'll let you look that up. Variables in multiple regression. There are multiple predictor variables. They can be categorical or continuous. One outcome variable is continuous. You have one variable in the outcome and it is a continuous variable. Multiple regression produces results detailing the extent to which each predictor variable is associated with the outcome variable. An example: at the conclusion of a smoking cessation workshop, instead of simply calculating the percentage of the participants that quit smoking, multiple regression is used to better comprehend the characteristics of those who succeeded based on data gathered from the survey card. And here's your survey card. What is your age? What is your annual gross income? Prior to this intervention, how many cigarettes did you smoke in an average day? What is your gender? What is your race, and how many cigarettes do you now smoke in an average day? I'm sure this was validated with a group of experts to find out what questions to ask. And if you're going to do a survey, you're going to do that validation process. Okay. Hypotheses. Age, income, baseline smoking, gender, and race do not influence one's success in a smoking cessation intervention. Well, we're hoping that it does, and that's the motivated hypothesis. This is based on data set from Chapter 13, Example 1, Multiple Regression Save. The pretest checklist. I'm going to show it to you. We're going to talk about it later. There are 5 things you have to find. That's why it takes so long to get to the point of painting the room. I always tell the kids, you want to help me paint? They don't like all the getting ready. They just want to get the paint out. Well, that's what we're going to do in this first video. We're going to get the paint out. We're going to disregard this for now and come back to it later. But you have an end quota. You have to check for something called linearity, homoscedasticity, multicollinearity, and normality. And these are things that you check. These first two you check before you do the multiple regression run, and the last 3 are something you check as a product of running the multiple regression. Okay, we got to speed up because we're not going to get through this. So if you're going to run the test, you click Analyze Regression Linear and start there. Moving, in this case, smoking status is the dependent variable. You know, we quit or not, how long we quit, what are we down to as far as number of cigarettes a day. Move gender, age, income, and cigarettes to independence, the independent variable column. Then select forward. Move race 1, race 2, race 3, and race 4 to the independents. Click statistics. Check R squared, change, and collinearity diagnostics. Let's talk about R squared. In the module just previous to this, you saw some, and we talked about R and R squared. R is sort of the magnitude of correlation. It has to do with the correlation coefficient. And R squared, if you square R, it tells you what percentage of the independent variable is related to the dependent variable. So we'll move on. And test run, click save, and then under the residuals, check unstandardized. So we can talk about standardization and unstandardized. You're talking about z-scores. So test run, click plots, and go from there. Move the z-score for the pre to the y-axis, the z-score for the residuals to the x-axis, and click continue. Test run, click OK, and then you get what we have right here. Age accounts for 53.1%. Now, you know how you get that number? That number comes from squaring the R value. You square that out. You just square 7 and you get 49. You see that's going to happen. So if you square 7.29. So squaring the R value, the magnitude of the correlation, gives you the percentage of the correlation. So that's what you have there. The pre-intervention was at 4.5% responsibility for what's going on in smoking cessation, and 2.1%. And as I said, the 0.04, we're not going to worry about it because it's not statistically significant. Race was forced into the model by the inner method. Since P was 0.671, greater than 0.05, it is not statistically significant, so we're not going to use it. The final R squared for this whole setup is, these are cumulative R squares. As you go along, they accumulate. And so it's 0.597, so you have to stop here because this last one was not significant. We're going to reject the hypothesis age, income, baseline, smoking, gender, and race do not influence one's success in smoking cessation. H1 we're going to say is what we'll accept. Age, income, baseline, smoking, gender, and or race influence one's success in a smoking cessation intervention. Here's the abstract. As a public service, the Acme Health Center advertises and offers a free 90-day smoking cessation program consisting of nurse-facilitated psychoeducational meetings, peer support from those who have been smoke-free for more than 1 year, and on and on and on. Tells you how to write your abstract, basically, and how you continue with the abstract. I guess this is the meat and potatoes of the abstract. Multiple recession analysis revealed an overall R squared of 59.597, wherein age accounts for 53.1% of the variability observed in the current smoking rate. Age accounts for an additional 4.5%, and gender accounts for 2.1%. And all this is statistically significant at an alpha equal to 0.05. Thank you.